Okay, so picking up where we left off, we're interested in comparing proportions, not simply estimating the proportions. Obviously, we have them uh, one on top of another, so it invites comparison, but we don't want to simply look at say, proportion of non-Latinos voting for Trump and proportion of Cubans supporting Trump and simply assume that the fact that one point estimate is less than the other means that the true proportions follow in that ordering. We need to incorporate uncertainty through standard error, and that's not simply gonna it's not going to work by simply using the standard errors we have for each of those estimates. That is, we can't simply look at the confidence interval for each proportion and ask whether the intervals overlap. So, yeah, we want this standard error for the difference in proportions, right? So there's a standard error, which is to say the standard deviation in the sampling distribution for statistic that we care about. Here, the statistic we care about is the difference between two estimated proportions, and that can be shown to be found by taking the sum of the variances for each of those proportions. I'm using sigma squared with the subscript referring to what it is the variance of. So it's the square of the standard deviation of the first estimated proportion plus the same for the second. I'm just keeping it generic right now. We're going to talk about the specific proportions we're interested in a moment. But anyway, so it's the sum of the two variances, the separate variances for the two proportions estimators, and then take the square root. So what that looks like, we remember, of course, the individual variances as being the underlying probability or proportion times 1 minus proportion divided by the sample size. Here we're going to be summing them together. So essentially the standard error for this difference in two estimated proportions is the square root of the sum of the variances of those two proportions. And this works because these two should not be correlated. If they were correlated, there'd be an extra term related to the correlation between the two. So just another reminder, as before, we can't really get the exact standard error, which is based on the actual proportions P1 and P2. We have an estimated standard error based on the estimates of those proportions. And starting with the point estimate of the differences, well, that's the easy part. We just take, in this case, we're going to look at choose to assume that what we're interested in is the difference between the proportion of Cuban voters in Florida voting for Trump and the non-Cuban Latinos voting for Trump. So we're taking a difference and estimating it as the difference in the individual estimates. So we have proportion of Cuban Floridians voting for Trump, 54%, minus the proportion of non-Cuban Latinos voting for Trump. So the Cuban portion of Latino vote versus the non-Cuban portion of Latino vote. And it's a big difference there, 28 points higher. So the estimated difference is 28% higher support for Trump among Cuban Floridians as opposed to non-Cuban Latino Floridians. And the standard error, now we're just kind of replacing the generic p hat 1 and p hat 2 with, don't be intimidated by all this, right? It's just the estimated standard error of our comparison of our difference is found as the square root of the individual squared standard errors. Right, so p hat for Cubans, 1 minus p hat for Cubans over the number of Cubans in the sample. Same for the non-Cuban Latinos. Remembering that these p hats again are referring to the proportion of that subpopulation voting for Trump in Florida. Okay, so just filling in 0.54 and 1 minus it, 0.26 and 1 minus that over their respective sample sizes. And we get 0.039, just about 4% as our standard error. And let's then find a couple of different confidence intervals. We'll do a 68% confidence interval. That's just adding and subtracting one standard error. So 28% difference plus or minus 4%, right? Which gives us a confidence interval of between a 24% and 32% greater vote for Trump among Cubans than non-Cuban Latinos in Florida. 95% confidence interval, more standard level of confidence. We have same point estimate, 28% gap, plus or minus 8%. So from 20% to 36% more for a higher vote for Trump among Cuban Floridians than among non-Cuban Latino Floridians. Okay, so again, we can get a narrower, a more precise estimate if we allow for lower confidence. We still feel more confident than not that this interval between 24 and 32% difference is going to capture whatever the true difference is in the population. We can be more confident that it's in this wider interval, right? I like to say, you could always get 100% confidence interval when you're talking about proportions if we just say it's, somewhere between 0 and 1, or somewhere between a -1 and negative 100% and positive 100%, right? So we obviously want a confidence interval that's more interesting than that gives some more information. And both of these do give some information. So we had non-Cuban Latino versus Cuban. Now let's actually look at Cuban population versus non-Latino altogether, right? So the non-Latinos in Florida. And these were, remember, fairly close. The point estimates, our best guesses were that the proportion of Cuban Floridians voting for Trump was 54% and non-Latinos in Florida were 51%. So if we want to know the difference, we may be interested in, maybe we're tempted to just assert actually that, Cuban Floridians are even bigger supporters on average of Trump than even non-Latinos. By creating a confidence interval around this difference, we can get a better sense of whether we're on firm ground by making that claim, or whether there's too much uncertainty to distinguish that difference from zero. That can we essentially rule out, for all intents and purposes, the possibility that maybe it's reversed. Maybe non-Latinos voted in higher proportion for Trump. So we take our estimate. We can subtract in either direction. I'm just choosing to go with the larger number minus the smaller. And so there's a 3-point difference, right? At least in our best guesses. But we want to allow for uncertainty. That's taking into account essentially the notion that if we had different samples of these same sizes, we'd be drawing random samples from the same populations. We'd get something different. We want to have a sense of how those differences might affect the final estimates that we get. Right? So we've got that 3% difference as our best guess of our difference. We want to say plus or minus something, right? So standard error of the difference in these two proportions, same calculated the same way as before. Numbers slightly different though, right? So the first piece is the same because it's still just based on the proportion of Cuban Floridians voting for Trump. And the second one, non-Latino Floridians voting for Trump. So 51% times 49% over the total. Notice small total number of Cubans in the of the overall sample, just 240. But we have 3,280 among the non-Latinos. And we wind up with a smaller standard error than before, 0.033. Based on why is that smaller? Well, most of what's driving it is the benefit of this very large non-Latino sample. So that denominator 3,280 is causing the overall standard error in the difference to be smaller. Last time it was 0.039. This is 0.033. Rounding to the second decimal place, 68% confidence interval. Well, we rounded, so it looks like from exactly 0 to 0.06, we can't rule out 0. In fact, because it was 0.033, if I'd left that third decimal place, we would have seen a negative number as the lower bound. So our 68% confidence interval overlaps 0. We can't rule out a reversal of signs there, but there's also a reasonable chance that the difference is as much as 6%, that Cubans vote for Trump in Florida by 6% greater number than non-Latinos. And 95% confidence interval, the standard width of interval. We get 0.03 plus or minus 0.07. So anywhere from negative 0.04 to 0.10. What does that mean? Well, it's within the plausible range of differences that, in fact, perhaps non-Latinos vote for Trump in Florida at 4% greater or 0.04 greater than Cuban Floridians, right? So anywhere from 4% in the opposite direction to Cuban Floridians voting for Trump at 10% greater numbers than non-Latinos.